Hi lads, how's it going? Today we're going to have a look at a part of conic sections, all right, and we'll discuss what conic sections are in a few seconds. So what we're going to be looking at today is a shape that's known as a parabola, okay? So this is a shape, lads, that you see all the time, okay? Every day you'll see this shape, but you probably don't know what it is or what kind of a shape it is. All right. So the easiest examples of a parabola is when you look at sports. Okay. So if you think of a basketball, a football when you kick it. All right. So basketball when you throw it, football when you kick it, or a slitter when you puck it. Okay. It takes a shape whereby if you split that shape in two, it's going to be the same for the first half of the kick and the same for the second half of the kick. Again, the same with a basketball here. You can see as you're throwing it, it reaches a certain point, which is at the very top. And once it reaches that point, it's going to come back down in a shape which mirrors the first half of the shape. So if your throw is a high looping throw, it's going to come back down in the exact same shape as the first half of that throw. So this side here is going to be the exact same as the right hand side. All right. So a few other examples here are there's an arch, stunt planes, there's a roller coaster, a water fountain is a good one. So if you just spray water up in the air with a hose, again, if you split that in two, the first half is going to mirror what the second half looks like. And again, that's a parabola. All right. So there's just a few examples, and it's a very common shape, I suppose, if you want to call it a shape. All right. So when I was speaking about conic sections there, the two which we're going to focus on is the ellipse and the parabola. All right. The ellipse we have already had a look at. All right. We've already had a fairly in-depth look at that, and all of you should be able to, or all of you can at this stage, I think, create an ellipse. All right. When we're talking about an ellipse and a parabola, I just want to have a quick look at what the differences are. All right. So the reason that we call them conic sections is basically a conic section is a shape which is given when we take a slice or a cut through a cone. All right. So if we look at an ellipse here, you can see that the rectangular shape is cutting plane, and that cutting plane is cutting through this cone here, and it's cutting both the left and right hand side of the cone as we were looking in the elevation. All right, so you can see that it's cutting both sides of the cone, and once it does that, you're going to get in a shape which is an ellipse. All right, if we flick back over here to the parabola, all right, again, you can see that you have your cone here. Again, we have a cutting plane, but this time we're only cutting one side of the cone, and the cutting plane is parallel to the opposite side over here. Okay, so you can just see in the orange the shape that's going to give us the parabola. All right, so I don't want to overcomplicate that, but that's just a quick synopsis of what conic sections are, what the ellipse is, where it comes from, what a parabola is. All right, so the examples here, we had a look at the basketball, football when you kick it, slitter when you hit it. All right, so obviously, lads, when you're playing soccer, basketball, or hurling, you can just imagine different types of shots yourselves. If you're going high with it, if you're going with a low driven kick pass into full forward line, if you're going with a low driven pass to hand with a hurley and a slitter, maybe 30 yards apart, you can see that you're going to have loads of different shapes of these parabolas. All right. Again, we said what a conic section was, and I just want you to sketch in. So I want you to take down all these notes, lads. All right, so pause the video as you need to go. We just said with the conic sections here that an ellipse is cutting two sides, parabola is cutting one side, and the cutting plane here is parallel to one of the sides of the cone. All right. The next thing that we want to have a look at, lads, and this is going to be important when we go having a deeper look into parabola, is the parts of it. All right, so there's a few different parts. Okay. I want you to just sketch this out, please, and I want you to just take down a very loose definition of the parts, which might stand us a little bit later down the line. All right. So the first thing is the axis. Okay, so the axis is basically a line of symmetry, which everything on the left is directly mirrored on the right. Okay, so if we put a line through any part of this at 90 degrees to the axis, the distance from the point on the parabola will be the exact same from center to here as it is from center to the right hand side. Okay, so the axis is a line of symmetry. Everything or every point on the parabola is the same distance from the left to the axis as it is from the right back into the axis. Okay, so if we were to write down a definition of that, it's just a line that divides a parabola in half. All right, we'll keep it nice and simple. The next thing that we're going to have a look at is the focus. Or sorry, we won't. We'll go with directrix. Okay, directrix is a line across the very top here. Okay, the parabola never reaches it, and it's a line which is at 90 degrees to the axis. Okay, so this symbol up here is just a 90-degree symbol. So it's at 90 degrees to the axis, which is this line running up through the center of our parabola. All right. The next thing that we'll have a look at is the vertex. All right. The vertex is the turning point of the parabola. So if you're talking about basketball, it's the very highest point that the basketball reaches. All right. So you can see that the vertex is up here. The focus, this is a really important one. Okay. The focus is down a distance on the line of axis. So it's always on the line of axis. And the distance that is down is equal to the distance from the directrix to the vertex. So these two distances here are the exact same. Okay, it's a fixed point in the axis, and again, just down here, the distance from the directrix to the vertex is equal to the distance from the vertex to the focus. All right, so just again to make that clear, what that is as this distance here is equal to the distance from directrix to the vertex. All right. So look, that's basically the key information that we need to know on the parabola. All right. So the next thing that we need to just have a little look at is how to create a parabola. All right. And there's two ways that you can create a parabola, but for the moment, we're only going to focus on one of these construction types. All right. So the way that we're going to do it, lads, is we're going to create a parabola within a rectangle. Okay, so the sizes of the rectangle will be given to you in a question. All right, I'm just going to do this freehand. It's not going to be to scale or too accurate. All right, but it'll give you an idea of how you create it. All right. The first thing that we want to do, lads, is we'll be given a rectangle of whatever size. We're going to just say 80 millimeters by, it might be 150 millimeters. Yeah. All right. And again, it's not to scale or anything. So just sketch it down when you're doing it also. So the first thing that we can put in this, lads, is we know that the axis is going to be in the center of this here, because everything on the left and the right are going to be a mirror of each other. So that axis is going to be halfway in our rectangle, and we can put a line straight through that. It's going to be at 40 millimeters, and that's going to give us our axis. All right. When we're creating this parabola, we're going to focus on one side first. All right. So if you can go back to the slitter, if you were standing down here in the bottom corner, you poke the ball. This is its highest point up here. We're not going to put in the directrix for the moment. The highest point up here is going to be the vertex. And when you pop the slitter up, this is the highest point it reaches, and it's going to fall back down over here. Okay. So just to try and simplify this, lads, and hopefully help some of you remember this. Okay. What I like to do is just on one half of this, we're going to pretend that this half is a running track. All right. So I suppose the method behind this is we're going to have to divide, or we might have a look at this on the book actually. Okay. So this is the method that we're going to use, right? So the first step is we're going to get our axis. So that's just dividing the top line, which we've done. The second step is we have to divide a line, the bottom line over here. I'll just focus in this again. So we're going to focus on two lines here, okay? We have the bottom line from E to B. We're going to divide that line into 4 parts. the amount of parts you divide it in depends on the size of the parabola. The more parts that you divide it in, the more accurate it is. All right, but you don't want to cluster it on either, so you don't want to overdo it. But you want to have maybe 4 or 5 in most if you can. Okay, if it's going to be larger, you might need a few more. Okay, so we divide this line into 4 parts. Or sorry, 1, 2, 3, 4, 5 parts. All right, so 1, 2, 3, 4, 5. We're going to do that up the side and across the bottom. All right, so we're dividing both these into 5 parts. Once we have this done, all right, we're drawing a line from our divisions on the bottom straight up through our rectangle. Okay, so when I was speaking about a running track, just a very easy way to remember it is you're after creating a running track on the left hand side of this parabola. All right, running track with 1, 2, 3, 4, 5 lanes. Okay. Once you have the running track created, we're going to do it like a little football drill or a drill in soccer, a drill in hurling, drill in rugby, whatever sport you want to do it in. What we're going to do is we're going to create a few 5, I suppose, 1, 2, 3, 4, or sorry, four lads lining up here. Okay, we're going to put a ball or a slit or a rugby ball or a basketball at each cone, we'll say at the side. So 1, 2, 3, and 4. We're going to have a slitter on each of these points. Okay, we're going to line up, and we're going to line up with the slowest lad at the start, the fastest lad at the very end. Okay, so the slowest lad is going to go to the first slitter. All right, so you're going to draw a line from the vertex, which is the top point here, which we're lining up, and this chap here, not the fastest, he's going to go to the first slitter. All right, where he breaks the line of the running track, the first line, because he's the first man, that's going to be a point on our parabola. All right, so right there, that's our first point. The second man steps up, is a little bit faster. He's going from the same starting point. This time he's running to slitter number 2, and he's going to pick that one up there. Okay, so you create this line where the second guy cuts the second running track line. That's a point on our parabola. So you can see the 2 is traced up from here. This lad is after hitting 2. Where they cross over, that's a point on our parabola. All right. Third lad, we're getting a little bit faster. He's going to the third slitter. When he picks that up, you're tracing back to the point where he cut line number 3. And again, that's a point on our parabola. The fourth lad, fastest out of the bunch, he's heading for the last slitter number 4. He's going to pick that, and again, where he cuts line number 4, that's a point in our parabola. All right, so that's going to give us 4 points. Okay, once you have those 4 points completed, you freehand, you start at the bottom corner, you come up through these 4 points, and you curve it into your vertex. All right, so once you've that done, you do the exact same at the opposite side. Okay, so it's the exact same process, except that it's mirrored across. So again, if you want to divide up your lines here, okay, divide it up into 5 parts, going down the side, divide it into 5 parts, and again, you're doing the exact same. First lad up, slowest of the bunch, he's getting the first ball over here. Where that cuts the running track line number 1, that's the first point in our parabola. All right, so if I was just to sketch that out again, and hopefully make it a little bit clearer. Or no, before we do that, I'll just flick this over. I have it on the sheet here. I think I have. We'll just have a quick look at how to divide a line into equal parts. All right, so if you can imagine the line AB here, that's one side of, or 1/2 even. I don't know, one side of our rectangle. For anyone that's a little bit confused or just to make sure you're very clear on it, anyone has forgotten it, hopefully you haven't, we'll just have a look at divide this line. All right, so we have the line AB. I'm bringing the line off it at any angle. Okay, so the line does not matter. It can be roughly at 30 degrees. It can be going at any angle. It doesn't matter, all right? So try and go roughly at 30 degrees. Once you have that done, I want to divide this line into, we're going to say 5 parts. All right, so I'm going to get my compass. You put it at the starting point of the line. You set your compass to any radius. Okay, don't go too small with it because it will be awkward. And you strike off that same radius 5 times. Okay, so 1, 2, 3, 4, 5. Okay, so you struck that 5 times. from the 5th point, you're drawing a line straight back to B, which is end of our line. Okay, and from there, I don't have a second set square, so I'll just use the back of a T-square. From here, you are going, you're going parallel. So I'm just going to set up my set square parallel to that last line, and you're just pushing it up till you hit the next compass line, and you're drawing a line from each of these points that we've created. Okay. So once you've that done, that's your line divided. Okay, so that's your division of the line. You can see we've 1 point here. We have our starting point, second point, third point, fourth point, fifth point is at the finish of the line. All right, so that's just a quick reminder there for anyone that did not remember how to divide a line. All right, so I'm going to take it that you know that now. All right, and I'm going to come back to creating our own parabola. All right, so the first thing we're doing is I'm going to come down and do it here. You could do it up on top. I have more room down here. I'm going to bring a line at any angle. I strike off 5 divisions with my compass. Again, you're doing this properly, lads. I'm just on this freehand to speed it up. Okay, the last point, you're joining that to the very end of the line. With your sliding set squares, you go parallel to that line from all your points. So all these lines are parallel. Okay, that'll give you the 5 divisions, and that's going to create your running track. All right, so once you've that done, you can just draw really light construction lines out straight up through your page, and that's our running track created. All right, so the next thing that we need to do is the same number of divisions. So 1, 2, 3, 4, 5 that we have down on bottom here. We need to create the exact same number of divisions up along the side. All right, so again, line at any angle. Start from here, strike off 5 divisions with your compass. The last one joins back to the last point. And again, from there, it's parallel lines with your sliding set squares. And once you've that done, you've your points created. Okay, so I'm just going to dot them in here so they're a little bit darker. All right, so once you've that done, lads, we're going to line up 5 balls here. It doesn't matter what type of balls, football, slitters, basketballs. We're going to create, this is our vertex. This is where our curve hits its highest point. We're going to create a line here of 1, 2, 3, 4. 4 lads of varying degrees of fitness or varying degrees of speed, right? So the first lad is the slowest lad. He comes up, he heads for the first ball. All right, ball number 1, we'll call it. Where that cuts the first line on our running track, that's the first point in our parabola. Second lad is up, he's going to go to the second ball. Okay, when he picks that, we have our line created. You can't see that, sorry, I'll darken that in. Okay, so when you're doing this, lads, it's a nice light construction line. Okay, so the first lad cut the first line. The second lad is going to ball number 2, where he cuts the second running track line. That's his point. Third lad, and this is the same all the way up. Third lad is going for the third ball, where he cuts the third line. That's our next point. The last lad, the fast guy. Okay, he's going for the last ball, ball number 4, where he cuts line number 4. That's the last point on our parabola. Okay, so once you've that done, it's then freehand up and try and get your curve in. When you've this done properly, lads, it'll look nice and okay. So I'll just darken that line in. All right, so that's one side of it done. Okay, that's the first half of the kick. The ball reaches its highest peak. It's going to drop that back down at the exact same angle. Okay, so for the purpose of these questions that we're going to look at, I want you to draw this process at both sides. Okay, so you're going to divide the line over here into 5. You're going to divide the line here into 5, and you're going to create the exact same shape going on this side. Now, once we've that perfected, and when we move on after the sheet, you could just bring a straight line across. Okay, we know that the distance from the axis and the center is the same to the left as it is to the right. So you could put your compass here, and you could turn that measurement straight around, and you could get it over the right hand side. The same here, you could bring a line perpendicular to your central axis. Put your compass here, it's the exact same to the left and the right, so you could swing this measurement over, you could get it over here, you could do the exact same for the following 2 points also. But for the moment, lads, we're not going to do it that way. We're going to do the full construction at both sides just to make sure that everyone gets used to the unit. Okay? All right, so that's how you create parabola. All right, so hopefully you should know the ins and outs of it after that bit of a spiel. All right, so at the back of your sheet, guys, if you have any 3 sheet, or even if you have a 4 sheet, just put on 2 sheets. I want you to create a number of parabolas. All right, so you could pause this as you're going along, or yeah, just pause it as you're going along. All right, so the first rectangle is 60 millimeters by 80 millimeters. I just put in a little rough direction of the shape that I want you to put it in. So the vertex in this one's going to be in the very top. All right, and the first thing that you're going to do with this, lads, is just go through your steps again. You create the central axis. Once you have that done, you divide up your lines. You create your running track. You lay out your balls. You let lads run to them, and where the lines cross over the running track, they're your points in the parabola. All right, so it's going to be the same method all the way through. So the main thing here, our vertex is at the center on top. This one here, all right, the shape is a little bit different. You can say this is, I suppose, a long driven foot pass in football, where it doesn't go as high, it stays at a lower trajectory, and it goes a longer distance. All right, again, if you divide this shape in 2, you'll get your vertex up here at the top, and your division of the lines remain the same. Divide off your lines down here, divide off your lines down here, and where they cross over, that's where you get your points. So that's 120 by 50. Over here, we just have a square, so it's going to be a different shape again. All right, so it's going to be 90 by 90. Again, your vertex is at the top. All right, so vertex straight down. Divide up this half first and complete this one first. The same for this one here, lads. Don't get confused with a different shape. Divide this in half. You're focusing on the left hand side first. Divide this into 5 parts. Divide this one here into 5 parts, and that's how you work it. The last 2, the exact same thing, lads, except we're putting a little bit of an angle in it just to make you think a little bit. All right, so you're starting at the bottom corner here. The line going up to the left is at 30 degrees, so you're 30 degrees set square. The line going up to the right is at 60 degrees, so you're 60 degrees set square. All right, so again, this is 95 millimeters by 60 millimeters. Your vertex is up the top here. The last one is 45 degrees set square. You have 120 millimeters by 60 millimeters. Vertex is up the top there. All right, so that's the layout of it. All right, can you get all those in the one shot? Yeah, you can. All right, so that's the layout of it, and that's your worksheet for this week. Okay, so if you have any issues, lads, get back to me, but hopefully you won't, and hopefully you'll have a fairly good understanding of it after that. Okay, so thank you very much.